Okay, so I have here what is hopefully the last piece of the puzzle when it comes to vacuum freeze drying food. This is a heater. So I built this to radiate heat down onto the food to drive the vacuum freeze drying process forward. Because if you don't actively drive it, then it takes ages for the solid water to leave the food and turn into water vapor, I guess, inside the vacuum. So you see I've got a little clip on the metal plate here. This plate is a stand-in for the pot that I do the vacuuming in, and there's a contact on the foot here. So when I drop this into the pot with about 20 volts on it, it heats up, and so that's putting out quite a lot of infrared heat. Also a lot of convected heat coming off the top of it, but in a vacuum that doesn't happen. So I am going to probably, once I've proved the concept, get a strip of alfoil and have it sit between the wood and the coils to reflect that the heat going down, because any heat that's radiated upwards doesn't do any work for me. So yeah, I'll hook up. I tested this earlier, and that's running at 20 volts and 7.3 amps, and that heats up the bottom of the pot to the point where it was too hot to touch. So that should do a pretty good job of heating up a little bit of mango. This is just to prove the concept that infrared heat from inside the chamber will work well. It's not really economical to run. Like, it takes about 10 hours to run a batch, and if I can do one circle of mango each time, it's going to be a long day. So this rig is sized to fit inside the pot. These screws are a poor enough conductor of heat, so the heat doesn't travel up into the wood and cause problems. These cable ties here might go funny with extended exposure to infrared radiation, but we'll see. The connector on the other pole goes to a little pigtail on the pressure gauge fitting in the lid of the vacuum chamber. So I conduct through the walls of the pot and through the pressure gauge on the top. So yeah, the aim was to get 3 ohms across here, but I ran out of nichrome, so instead of 3 9-ohm resistors in parallel, I had to go with 3 6s. So it's not using all the power that my 30 volt 10 amp benchtop supply can put out, but a fair bit. So I've had this running in the vacuum chamber just with no food in there and no cold trap, just to prove that nothing goes kaboomy, and so far so good. It's interesting to note I can put a lot more power into it when it's in a vacuum than I can when it's in atmosphere, because the nichrome burns before it melts, so I can crank it up quite a lot higher when it's in the vacuum, which is interesting. But that is putting out a shocking amount of heat. I probably won't need it to run this hot. I'll probably run it at maybe 5 amps or something when I'm actually drying, because I have to have a phase where I do the superficial drying, I think it's called, where you just get the surface moisture off, and then after a while you crank on the heat to drive off the rest of the solid water. I'm probably also going to have it on the hot plate to heat the pot from the bottom as well. So this weekend I'll give it a shot. Okay, bye.